In chapter 6.3, we're continuing with the normal curve. So if you recall, that comes from a symmetrical distribution. We will also be using the Z table that was introduced earlier. And so you need to be sure that you can correctly find your probabilities off of the table. So now we're going to just continue on. So what we're going to be looking at is bringing everything we've learned so far in chapter 6 together. So we're going to look at the steps to find any area or probability for a normal distribution. So it says first convert the raw scores, and raw scores are X values, into standardized scores, which are Z values. Now what you need to remember here is most typically in a problem, the raw score of the X value will be given because that's a real life value. Then once we've converted into our standardized values, then we go to the table and we find the probability. And then of course you have to be sure that you correctly use the table. Remembering that if it's a less than, you use the number directly from the table. If it's greater than, 1 minus the number from the table. And if it's in between two values, then you take the larger minus the smaller from the table. So in this first example, we are going to assume normal distribution, and we are asked to find the probability that X is greater than or equal to 2. Now be sure you pay attention to this inequality, because then that directs how you will use the table. But first, we are given this X value because it states it's an X, so we know 2 is an X. We're given mu and we're given sigma. So the first thing that I need to do is convert this raw score of a 2 into its standardized score. And that's X minus mu divided by sigma. And when you calculate that, you get -4. And I'm going to go ahead and put -4.00 because we always round Z values to 2 decimal places. So now I can go to the table. So we're going to find the probability that X is greater than or equal to 2. And since it's a greater than statement, I know I'm going to do 1 minus the number from the table. So we talked about this a little bit at the end of the last lesson, and -4 is not on the table. So you have to pay attention to the small print at the bottom that says for any number smaller than -3.49, use 0. So I'm just going to use 0. So my answer is 1. Now, in this next example, we are finding the probability that X falls between 10 and 26. So since I have 2 X values, I'm going to need to convert each of those into their standardized. So I would have 10 minus 15 divided by 4. And then the second one would be 26 minus 15 divided by 4. So I'm going to put both of those into the calculator. And just recall whether when you're converting into a standardized or a Z value, you always round to 2 decimal places. So this is -1.25 and this is 2.75. Now what I'm going to do is I'm going to go to the Z table and I'm going to find the probabilities that lie to the left of both of these. So first I'm going to find -1.2. So here's -1.2, and then at the top I'm going to look for 0.05, and I'm going to come down and I find 0.1056. And this is the area that lies to the left of this. And then I'm going to look up 2.75. Whoops, that's not the right. Here we go. 2.7. And then at the top, 0.05. And it gives me 0.9970. Because when we're looking for the probability that falls between two numbers, then I'm going to subtract these probabilities. So the probability that X is between 10 and 26 is 0.9975. Let me make sure of that. Sorry, that is 0.9970. I must have been looking at the wrong one, or I said the wrong thing. 0.9970 minus 0.1056. And when we do that subtraction, you get 0.8914. I'm going to triple check this at 2.75. Yep, it's 0.9970. There's where you can see all the numbers. All right, so now we're going to take it to kind of like an application or a word problem so you know how to pull the numbers out. Police response time to an emergency is normally distributed, and this again is important because this is what allows me to use the z-table. If it wasn't normally distributed, I can't use the z-table. With a mean of 8.4 minutes, and I always like to write my values, pull them out of the problem, and a standard deviation of 1.7. So part A says find the probability that the wait is between 5 and 10 minutes. Now, this doesn't have an x or a z with it. So how do I know if it's an x value or a z value? Well, an x value is a real life value. A z value tells you how many standard deviations away from the mean that you are. So when I see that this 5 and this 10 is talking about minutes, that is a real life value. So I know they have given me x values. So it would look like this. So again, I have x values, so the first thing that I need to do is convert both of these values into their standardized or z values. So I would have 5 minus 8.4 divided by 1.7 and 10 minus 8.4 divided by 1.7. And when I calculate my z values, I always go to 2 decimal places. So this is -2, and I'm going to go ahead and write -2.00. And this next one is a decimal that goes for a while. Just use normal rounding rules. So now we're going to go to the table, and we're going to look for -2.00. -2.00, so it's 0.0228. And then I'm going to look up 0.94, so 0.8264. And when it falls between, then we know that we always subtract the larger minus the smaller. So the probability that x is between 5 and 10 is going to be 0.8264 minus 0.0228, which gives me 0.8036. And this, part B, the probability that the wait is less than 5 minutes. So this is reading the probability that x is less than 5 minutes. So again, we need to calculate the z. Well, I go, didn't we just do that up here? And sure enough, we did. I'm not going to rewrite it. We found it when it was 5, so we know this is -2.00. So now I just need to address how to use the table. And since this is a less than, it tells me just use the number from the table, which we already found here. So it's 0.0228. Had this been a greater than, then we would have done 1 minus 0.0228. All right, another example. the cassette deck life is normally distributed with a mean of 2.3 years and a standard deviation of 0.4. We want to know the probability that a cassette deck will break down during the guarantee period of 2 years. All right, well, how am I going to label 2? Well, 2 years, it's talking about a real life value, so I know this is an X value. Now, on the previous examples, I did not draw the curve. You don't have to. I am going to on this one, just to get a little refresher, plus so we need to discuss whether it's a less than, greater than problem. So mu is 2.3. And as I go to the right, I'm going to add 0.4. So this would be 2.7, 3.1, 3.5. So this deals with 2.7 years, 3.1 years, 3.5 years. And as I go to the left, I subtract 0.4. So 1.9, 1.5 years, 1.1 year. Okay? Now, don't forget, if we were talking about standardized, this would be 0, 1, 2, 3, -1, -2, -3. And what we have is an X value of 2 years. So here's 1.9. So I would approximate X equals 2 years about here. Now, what we need to figure out is a guaranteed period of 2 years. So when do they guarantee this cassette? Is it when we shade to the left? So when it breaks down from when you buy it up to 2 years? Or do they guarantee it from not when you first buy it, but once you hit 2 years and as it gets older? Well, hopefully that makes sense to you, that you know that they guarantee it from the time you buy it up until the 2 year period. So what we're dealing with is a less than statement here. So we want to know the probability that they will guarantee it in 2 years. So that would be less than. We're given a real life value. So the first thing that we need to do is convert it to its equivalent Z value. So 2 minus 2.3 divided by 0.4, and that calculates to -0.75. This is a less than statement, so all I have to do is go to the table and use that number. -7, or I'm sorry, -0.75, 0.2266. So basically, here's what this is saying. 22.66% of the time, the cassette deck is going to break down and need to be replaced. So if you're the owner of the company, that seems awfully high. You're basically between 1 in 5 and 1 in 4 that you sell, you're having to repair and replace. My guess is they're going to want to make some adjustments to their guarantee period. Okay, so what we have been doing is we've been taking, I'm going to do this. We have been given a raw score, which is also known as an X value. And then to find its probability, we then have converted that to its standardized score, which is a Z value. And then we have gone to the table to find the probability. So this is the sequence of events that we've been doing. This is what's given. We calculated the Z value. We go to the table and appropriately use the table to find the probability. Now Now the reason I did that is because now we are going to do inverse normal distribution, which basically means we're using the z-table backwards. So on the z-table, we have been calculating the z, locate the z, and then find the probability. Now we're going to do it backwards, which means we're going to start with the probability, and we're going to have to work outward to find the z value. So now when we do the inverse of this, given will be the probability. And the thing to remember about this is the probability will either be given to you as a percent or as a decimal. So that's kind of a hint. Then we will go to the table to find the appropriate standardized value or standardized score, which is your z value, and that's where we worked backwards. And then sometimes once we find this, we then need to calculate the raw score or the x value by using x equals z times sigma plus mu. So that's kind of the process. So here are the steps. We will look for the area or the probability that is given inside the table. Look to the side and the top to find the appropriate z value, and then use the formula to convert that z value to the x value. It says if necessary, that's if it's asking you to find the x value. Sometimes it's just asking you to find the z value. Okay, so let's take a look at what this looks like. All right, so notice this says find z. Well, if it says find z, that means the z value was not given. Here's why I point that out. I will have so many students that will take this, and it tells me that 5.2% of the standard normal curve, so here's my standard normal curve, 5.2% of it lies to the left. I'll have so many students that will try to force this number into a z value. Notice it is a percentage. This number right here is the area or the probability that is given. So it's telling you how much of the curve is shaded in. So I'm going to shade in 5.2%, and I'm going to shade it to the left. Okay, well, let's look at, I always draw what cuts it in half. So this is mu. So if I shaded to the left of mu, I would be shading in 50% of the curve. And this is telling me to shade to the left, but it only wants me to shade 5.2%. So I know that forces my z value to be a negative number. So this is approximately what I have done is I have shaded in 5.2%. So this is my area. Now on the table they show the area as a probability or in decimal form. So I'm going to rewrite this as 0.0520. So this is the probability that I'm going to look for on my table. Well, I know my z value has to be a negative number because it's to the left of mu. So I'm going to look at my negative, and I start out by just looking for 0.05. Now here's where you need to be careful. Now I'm going to enlarge this. I'll have a lot of students that will go, oh, here's a 5, but be careful, that's 0.005. We're looking for 0.05. So here's 0.2, 0.3, 0.4. And I go, here's some 0.05s. I'm looking for 0.0520. Oh, wow. I have found these two right here. Now, unfortunately, I did not find the exact number that I'm looking for. I wanted 0.0520. Well, I can't find that exact number, but I do know the number I'm looking for falls in between these two values. So here's what I'm going to do over here. Go back to this. I'm going to write down the two numbers that I did find. And I found 0.0526 and I found 0.0516. And I know the number that I'm looking for falls in between these two. All right, so what I'm going to do is I'm going to find the z-values that are associated with these two numbers. So now I'm going to go back to the z-table. And I say, okay, it's -1.6. And then I'm just going to go up to find out the numbers that go in the hundredths place. So if I travel upward, then I get 2 and 3. So what I have found is that this is the z-value, -1.62, and this has the z-value of -1.63. All right, now I need to know what z-value I need to place to associate with 5.2%. So here's the question you ask yourself. Which is it closer to? So here's what I'm basically asking you. We're looking for 0.0520. So which one is this closer to? So I would just take my calculator if you don't see it, but just so people will understand what I'm doing, I'm going to take 0.0526 minus 0.0520, and it has a difference of 0.0006. Then I'm going to take 0.0520 minus 0.0516, and it has a difference of 0.0004, which tells me then that it is closer to this one. So this is going to be the z-value that we use. So if I go back to my picture, I am going to use z is equal to -1.63. So this right here, it said find z. This is what it's asking me to find. So my answer would be -1.63. All right, let's do another example. All right, so again, find z such that 5%, so this is given as a percent, so I know this is area or probability. So that's how much of the standard normal curve will be shaded in. But now it's going to have me shade to the right of z. So this one is a little bit different. All right, so I have my curve. And I'm going to find mu. Now, I'm not shading in very much, but I'm not going to go over here and shade 5% because it tells me to shade it to the right. So what it's asking me to do is to shade 5% to the right, which would be here. Now, here's what you need to realize. This is where things are a little different. I'm going to zoom this in. All right, so it is telling me that to the right is 5%. Well, my table is a left-held table. So in order to find this z-value, I need to know how much area lies to the left because we have a left-held table. Well, if the total area under the curve is 100% and this in yellow is 5%, then I know this has to be 95%. So since our table is left-tailed, we're going to be looking for this 0.9500. Also, because we shaded 5% to the right, that forces this z-value to be a positive z-value. All right, so I'm looking for 0.95. So here's a 9394. Okay, here's a 95. I need 9500. Well, if I go this way, it's getting bigger. So I'm going to go to the left. Nope, I need to come up here. 9500. Well, there's 9505. And here's 9495. So the one I'm looking for falls in between these two. So I'm going to write these two numbers. I'm going to do it over here like we did before. So we found 0.9495 and we found 0.9505. And I want to find the z-values that is associated with. So we're at 1.6. And I come up 4 and 5. So this z is 1.64. This z is 1.65. And what we're looking for is right here in between, and that's the 0.9500 is what we're looking for. All right, so again, I'm going to ask, which one is it closer to? So I go, okay. You always take the larger number minus the smaller number. So in this case, I'm going to take 0.9505 minus 0.9500. And the difference between that is 0.0005. Then I'm going to do 0.9500 minus 0.9495. It's 0.0005 again. All right, so this is one of those unusual cases where it is smack dab in between. It's not closer to this one or this one. All right, so when it's smack dab in the middle, what you do is you take the two z-values and you average them. Whoops, got to be able to spell average. Average the two z-values. And you only do this when it's smack dab in the middle. If it was closer to one of the others, you would use the one it's closer to. But when it's smack dab in the middle, so our z is going to be 1.64 plus 1.65 divided by 2, which is 1.645. This is one of the rare cases, or the not very often cases, in which your z-value is 3 decimal places. And we do not round it in this situation. So the z we're looking for is 1.645. All right, so far we've looked at 2 scenarios using the inverse normal distribution, when we shade to the left, when we shade to the right. And we're going to have another situation. Hang on a second, I'm recording a lecture. Thanks. I had a student walk in, so sorry about that. And then we have another situation, and again, we're still finding z, but now 90% of the standard normal curve lies between 2 numbers. So now we're going to look at when we have the shading is between 2 z's. Now, what this tells me right here is one of my z's will be negative and one of them will be positive. And what they are is they are opposites, which means they are the exact same numbers, just one of them is positive and one of them is negative. So my z-values are symmetrical around the mean, so it means they're the same distance from the mean. So this will be my negative z. Here I will have my positive z. And this shading here is 90%. Okay, let me zoom that. All right, so again though, we only deal with left tails. So to find this negative z right here, I would have to know the area of that non-shaded. Well, is that possible to find out? Well, we know the complete curve is 100%. If this is 90%, then I know these two are together 10%. And since it's symmetrical, we know that this is 5% and this is 5%. So I know the area that's to the left of my negative z is 5%, or 0.0500. And I know this is a negative z value. All right, so I'm going to go to my table. Let me erase where I had written before. And we are looking for 0.0500. Well, here's 0.0505. So I find these two right here. And what we're looking for falls in between. So I'm going to write those two numbers. So what we're looking for is the negative z, and we located 0.0505 and 0.0495. And what we're looking for falls in between 0.0500. And what are those z values that it's associated with? Negative 1.6, four and 5. So we have negative 1.64, negative 1.65. Now, the first thing that you're going to ask yourself is, which one is it closer to? And what you're going to find is it's smack dab in the middle. So when it's smack dab in the middle, again, we're going to average the z values. So my z is going to be negative 1.64 plus negative 1.65, and we're going to divide that by 2, which gives me negative 1.645. So we know that we have found this z to be negative 1.645. Now, here's what is awesome about that, is once we've found one of them, then we automatically know this one because they're opposites. So since they're opposites, we know this is positive 1.645. And guess what? We can prove that because this positive z value, the amount that lies to the left is the 90 plus the 5, which is the 95%. Well, we just found that one over here. 95% was 1.645. So we know we are correct on that. So there are the different ways that you will be asked to use the table in the inverse when you are given the probability. So let's look at a couple examples to finish out this section. All right. So we're given mu, we're given sigma, we're assuming normal distribution. And this reads, what is the probability that x is less than some number such that it equals 12.3%? This number right here would be your x value. That's what is missing. This number right here is what is given, which is your area. So since we're given the area, we know that we're going to use the table, the inverse normal distribution. So for my visual learners, if you need to see what this looks like, we're shading in 12.3%, and we're shading which direction? This inequality is less than, so we know we are shading to the left. this is 12.3%, which is 1.230. Now, before I can get to the x value, I need to find what this z value is. I know my z value is negative because it's to the left of mu, so I'm looking for 0.1230 on my negative z table. So I'm looking for 0.12, so here's 0.09, 0.1, here's 0.1292, and ooh, yay! I love it when it falls directly on there. So 0.1230, it's negative 1.16. So z is equal to negative 1.16. So now that I have the z, I need to find the x value. And how do I do that? X equals z times sigma plus mu. And round to 2 decimal places. So my x value, the value that it's looking for is 14.68. All right, last example. A video game company wants to advertise a guarantee policy that will refund the full price of a computer if it fails during the guarantee period. The mean life for the computer is 28 months. So the mean life is 28 months with a standard deviation of 5 months. The computer life is normally distributed. So that just tells me I can use the Z table. All right, first question. If the company guarantees a full refund on any computer for 2 years after purchase, what percentage of its computers will the company expect to replace? All right, so I've got to figure out what is 2. It's 2 years, that's a real life value, so this is an X value. And this is similar to the last example we did on the last page, a guaranteed life. So it's asking for the probability that X is less than 2 years. Now, in this problem, you're going to need to be a little bit careful. Mu and sigma were given to me in months. So in order to calculate my Z, I need them all in years or all in months. So the easiest thing would be to do is to convert this 2 years into 24 months. So now what we're going to do is calculate the Z value, 24 minus 28 divided by 5, and that is negative 0.80. So I'm going to go to my table now to find the probability, and it is a less than statement, so I just use the number from the table. Whoops. All right, so negative 0.80 is 0.2119. And it said what percentage? So this would be 21.19% of the time they're having to repair or replace the computers. Now, in this problem, we were given X, calculated the Z, went to the table and found the probability. So you've got to pay attention to what is given. In this second problem, it says if the company does not want to make refunds on more than 12%, they give me a percent. So now they're giving me area probability. How long should the guarantee period be? So now here they're saying the probability that X is less than what equals 12%. So now they give me the area, so now we're doing this backwards or in reverse. They give me the probability, I go to the table to find the Z value, then I substituted it into the formula to find the raw. So what we've got to do is find the Z value, and I'm going to be looking for 0.1200. Now, if you have a trouble knowing if this is a positive or a negative z-value, here would be mu. We're shading to the left and we're only shading in 12%. So I know that forces my z-value to be negative. So I'm going to go the negative one, and I'm looking for 0.1200. There's 1, 2, 1, 2. Okay, it looks like it's going to be in between two values. So I found 0.1210. So I found 0.1210 and 0.1190. And we're looking for 0.1200. So we first want to ask ourselves, which one is it closer to? Oh wait, what z values are those? Let's see, that this is z of negative 1.17, and this z is negative 1.18. Okay, so which one is it closer to? Well, I can look at this one. It's 0.0010, 0.0010. So this one is smack dab in the middle, so I need to average this and this. So add them and divide by 2, and you get z equals negative 1.175. So now to find this x, we're going to do negative 1.175 times sigma plus mu. Whoops, mu is 28, which equals 22.125. So I'm going to round that to 22. So this goes here, which would be 22 months. So in this, the main thing is recognizing what's given and which direction to go. So pay attention to what's given, and then you'll know which sequence of steps to use. That completes 6.3.